What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. Today, we're talking about convection. What time is it? It's science time. Welcome back to DIY Science Time. My name's Mr. C, and I'm so glad that you're here to be part of our science crew today. We are talking about convection today. That's right, convection. And what inspired this was this cup of tea. I wanted to make some tea, and when I turned on my kettle, I started to notice something. Check it out. This is so cool. You can actually see the hot water rising, and then it's coming over, and then it's settling. This is a convection current. And I know what you're thinking. Mr. C, it's actually so difficult to see what's going on because the water is transparent. Well, guess what? I've got some amazing experiments that we're going to try today to let you see convection in action. But first, you need to gather some materials. Alfred, let them know what we need.
Make sure you have the following materials to experiment along with the crew. Fish tank or clear container, an ice cube tray, blue and red food coloring, a small cup, and best of all, your moving and grooving science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
We're building our very own convection aquarium. First thing we need to do is make some ice. And we want our ice to actually be blue, so I have some food coloring, some water, some drops, a stir stick, and now we're going to fill this up. We need to get this into the freezer, but we also need to fill up our container with water. So here is our first half gallon. We're going to need more water for sure. All right, so our fish tank, or should I say convection aquarium, is filled about 3/4 full of water. We have our ice cubes that have been in the freezer for quite some time. I'm going to pop those out. Just set that aside. Now, we're gonna have ice cubes, and we're gonna place them into the tank up top right here. And because ice cubes are ice, they float. And then I'm going to fill this with hot water. And I'm gonna make it red to represent hot. I'm gonna pour that into there. All right. We're gonna put a couple of drops of red food coloring. All right, so I'm gonna put the ice cubes in first, and our job here is to simply observe what happens. Stay over here, buddy. Whoa. All right. And I'm going to place this in the water over here. Try to keep this over here. We're gonna see what happens. I'm gonna add a few more ice cubes. And now we wait. Oh, that's so cool. You can actually see the blue is falling and the red is rising. The cold water is more dense than the water around it, so it begins to fall. The warm water out of our other container is warmer, so it begins to rise. As you can see where we are with the tank, there is a definitive line up top with red water. That's because this is warmer water, and the warmer water is less dense. Now, we can also see on the bottom of the tank, where we saw it before, it's really, really blue. That's because the colder water is more dense and it sank to the bottom. What was happening over time is the hot water was coming up, and then it was meeting the cold, and it started to cool, and then it started to fall, and it started to go back over, and we have this convection current. This is our first example of convection today, and I hope you give this experiment a try. Convection refers to how fluids move. We can see a convection current occur in this tank of water. The warmer water has more kinetic energy, which means those molecules are able to move faster and spread apart further. This makes the warm water less dense than the surrounding cold water. As the warm water rises, the colder water, which is more dense, sinks into the area where the warm water originally was. This continuation of the warmer water rising and the cooler water sinking is a perfect example of a convection current.
Did you know that hot air balloons are another great example of convection at work?
All right, so we're here at Gentle Breeze Hot Air Ballooning in Lebanon, Ohio. We're actually gonna be going up in the air here in a bit. I cannot wait to explore air from way up there. Hey everybody, we're here at Warren County Airport in Lebanon, Ohio, and I'm with Mark Weissman, who is going to be my pilot in the hot air balloon. Mark, how are you today?
Good, how are you?
I'm doing great. I'm a little nervous, but talk to me about a hot air balloon. How does it actually work?
As you can see behind us, there's a basket, and then there's the balloon, which is called the envelope, and we are going to fill it up with cold air.
This is so cool. All that air is filling up this balloon.
And once that cold air fills the balloon up, we will heat it up, heat that air up, and that's what causes it to rise. We are in a balloon that's 69,000 cubic feet. So to get a perspective, if you were to turn it upside down, you could fit 69,000 basketballs in it.
So we're actually up in the air flying. Every time we want to raise and go higher in this balloon, we give the burner a pull. So we've been flying for about a half an hour, and we're coming in for a landing here. And we are literally scraping the dirt intentionally. We're just super low to the ground. This is so amazing to be able to fly, to make adjustments with a pull of a lever to heat up more air and create lift and cause that air to become less dense than the surrounding air. It's amazing. We're coming in for a landing.
We're gonna bounce a couple times.
Hold on here.
Yeah,
we got it. We got it. We're on the ground.
We're just landing.
For this next experiment, you'll need 2 plastic cups, water, and an index card. You might want to work over a catch pan, just in case the water spills. Carefully fill 1 glass with warm water and add a drop of red food coloring. Fill the second glass with ice water and add a drop of blue food coloring. Place the index card onto the cold water cup and turn it upside down. Surface tension should hold the card in place and prevent the water from spilling out. Carefully place the cold water cup on top of the warm water cup and gently pull the card from in between the 2 cups. Watch what happens to the water. The 2 colors mix to make purple. Now try it again. But this time, place the card onto the warm water first. Carefully turn the warm cup upside down and balance it on the cold water. Gently pull the card out to see what happens this time. It doesn't mix. This happens because the hot water is less dense than the cold water. The hot water wants to rise and the cold water wants to sink, so they don't mix this time. This fun little science trick is a great way to illustrate how the water behaves differently when it has different amounts of energy.
Convection, convection, convection.
Convection!
Cell. That's right, I 3D printed this little box because I wanted to see if we could see convection in a different way using some smoke. So what I have here is a little box I 3D printed. I have a candle over here in the corner. We're gonna light that. And then we're going to close the box. Just like that. So we have a heat source on this side of the box, and we don't have a heat source on this side of the box. Now, I also have some incense, and this incense, when you light it, it produces a really nice smell. This one is lavender, but it also produces smoke. And as you can see, the smoke is rising, all right? But what happens if I bring the smoke over to my convection cell? Some of it rises, but a lot of it is being sucked down into the cell. And this is because of the convection current that's taking place within the cell. The candle is heating up the air on this side, and the hot air is rising. The cold or cooler air over here is being pulled down into the area of lower pressure, and then we have the cell and this current taking place. The convection current's happening. It's pretty cool. And with the smoke, it allows us to actually see what's happening. And while I'm talking, I'm disrupting the smoke right here, so I'm trying to talk like this so not to mess it up. But we can literally see the smoke coming down, being pulled over, and coming out the other tube. So there you have it. That is a convection cell, and it allows us to illustrate convection using smoke. And it smells good.
That water experiment from Riley was so unexpected. I made a note that we observed similar convection patterns with the fish tanks, cups, and convection cell. Always remember, if you're working with open flames, you should always have an adult there to help and supervise. Science safety is the name of the game.
Nothing like a nice cool breeze on a hot summer day. But did you know that there's some science to why wind can help you cool down? Place your hands in front of the fan. The cool air moving through your fingertips feels nice. Now dip your hand in water and place it in front of the fan too. Does one hand feel colder than the other? The hand that is wet should feel cooler than the dry hand. This cooling sensation is because the air moving across your wet hand causes the water to evaporate. The water pulls heat energy from your hand as it evaporates, leaving your skin feeling cool.
You want to talk about keeping your cool? Here's a cool fact. Our body has about 2.6 million sweat glands. Sweat is made up of water and other minerals called electrolytes. When our body senses an increase in temperature, it jumps into action to get those sweat glands to produce sweat on our skin, so convection can do its job and cool you down. So if you start sweating, don't sweat it. Your body has it all under control.
This convection spinner is a really interesting experiment demonstration. And why is it so interesting? Well, we know that flame is hot. Flame burns at about 1200 degrees Fahrenheit. That hot air is rising. As it's rising, it's going straight up and it's pushing the slanted part, sort of like the slide, out of the way. And that push, as it rises up, is causing this to spin and to spin over and over again. Now you might be saying, how do I make one of these? Well, I'm going to show you. But first things first, science safety. That's right, because we're working with flame, you should have an adult with you who is able to watch and observe and be close there just in case something were to happen. We don't want to be playing with flame at all without adult supervision. All right, let me blow this out so that we can stay focused on what we actually need to do. All right, we're gonna let that smoke dissipate, and while it's dissipating, I'm gonna take this masking tape and I'm going to draw a circle on my aluminum foil. Identify the center, and then I'm just going to make a spiral all the way out, just like that. Now you're going to take your foil and you're going to cut out a square around your circle, just so that it's easier to start with. And now I'm going to cut out my circle. I'm cutting on the inside of the line instead of the outside. And when you get to the top, you can kind of stop. There we go, just like that. All right, so I'm gonna take this one off, and I'm gonna show you how we set this up. So here's our candle. I took a skewer stick, and I actually just put it next to the candle, and I kind of just gently bent it over this way, right? Because the heat from the candle is rising straight up. So we want our convection piece to slide over it, just like that. Now it's a little bit long, so what I'm going to do is I'm actually going to cut off just the smallest part, and then I'm going to kind of crease it so it kind of bends upwards, just like this. And we're just gonna see if it works. Let's give it a try. I think the top here is not working. Whoops. And there you go. A convection carousel. It's a really simple design, and it works really, really well. And it's all about convection. That hot air is rising, it's pushing the slanted part out of the way, and because it's pushing it into a spiral, it keeps spinning and spinning and spinning. And just one more reminder, this experiment needs to be done with adult supervision.
I have another fun experiment to show what happens to air on Earth's surface as it is heated. Place a clear plastic container onto 4 styrofoam cups. Fill the container with water and allow it to settle so it does not move at all. The water is going to represent air molecules. Carefully take a pipette and place red food coloring into the center of the container. Be careful not to mix the water. Now carefully place blue food coloring on each side of the red food coloring. The red will represent the warming air, and the blue will represent the colder air. Once a container is set up, place a styrofoam cup filled with hot water directly under the red food coloring. The hot water represents the uneven heating of the Earth's surface. As the hot air rises, it's creating an area of low pressure. We can see the blue food coloring, which represents cold air, begins to move into the area of low pressure. This is a great way to represent convection, which creates an air movement or wind.
Convection, convection, convection!
Convection, convection, convection! Convection, convection, convection!
I've got another experiment for you. This time we're going to use a hot plate and some aluminum pie pans to make convection cells. Now you're going to need this special stuff. This is called soap.
Soap.
And the soap you're looking for has a very shiny property to it. So you can see here it's like really shiny and it's almost like pearly. This is what you are looking for. And so the experiment you're going to do is actually looking for and finding the best soap to make the convection cells in the pan. So this is part of the process, and this is half the fun, is figuring out what soap works best. Now, first thing you need to do is add some water to your pan. We're going to add some soap. Oh, that's a whole different episode. All right, now you're going to swish it around. And I need way more soap than that. And what we want to do is make this mixture homogeneous, which means we want to get it nice and mixed up so that we can see no clumps in there. We want it to be nice and smooth. So we're going to work to get that mixed up. You're going to notice I'm doing this away from the hot plate. I'm not mixing this with my fingers over the hot plate. Science safety is important. Now this is something you're going to want to do with a family member or a crew member that is older and responsible, because you're going to be working with a little bit of heat with this hot plate. I'm going to put just a little bit more soap in. I want it to be really translucent, so I want it to be nice and cloudy. I don't want the light coming through. I don't want to see the bottom of the pan. I just want to be able to see the soap. And you can see that the water has that shiny, shimmery quality to it as well. All right, so I think it's almost mixed up the way I want it. I'm going to lift this up really carefully. Set it onto the burner. And now I'm going to turn it on medium. And now we have to wait.
And wait.
And wait.
So it might be hard to see it, so I'm going to add a drop of food coloring. The food coloring begins to move on its own. That's because of convection. The food coloring eventually moves through the entire pan, allowing us to see the individual convection cells. Each convection cell is a zone where there is upward motion of warmer fluid in the center and a downward motion of cooler fluid at the edges of the cell. We can see lots of convection cells in this pan. I also wanted to try it with different colors. This yellow allows me to see the cells, but adding the red really lets me see how the fluid is moving in the pan. Try using different soaps and shampoos to see which ones work best for you.
All these demonstrations have had me circulating through my notes to make sure we've included all of these cool facts and experiments. Convection occurs in fluids like air and water. I think these notes about staying cool will really come in handy when the weather gets hot. I included an image from Riley's experiment because it allows us to see how convection currents could impact weather and create wind and storms. There is so much more to learn when it comes to convection, and we've only just scratched at the surface. Speaking of surfaces, you should consider researching magma and how it flows under the Earth's surface. I think you might be surprised by the convection currents flowing deep underground.
Convection. Such a busy day learning today, and so much fun. We got ourselves moving, and literally, convection moves me. But here's the thing. I put all my notes into a science notebook. And why did I do that? So I can hop back in there anytime and take a peek at what I learned today. Convection cells, convection carousels, convection to heat up water to make my delicious tea. That's right. We had so much fun. I want you to keep learning. I want you to keep having fun. I want you to keep exploring. And I want you to always remember that science is wherever you are. Take care, everybody. Bye.
Science time.
Here we go. Pip, pip, cheerio. You ready? Anytime you have a difference in temperature, boom, 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 like we did with that water tank. Water tank. That is super cool. This, I don't even know what it's called. Like carousel? What is it called?